Okay, let's look at this concept. I think this is concept number 3. The state of Maine in the United States, USA, is famous for its lakes. There's a lot of lakes over there. There are more than 2,000 named lakes in Maine, which is located in the northeastern seaboard of the USA. In addition, there are more than 4,000 other lakes in the state that are greater than 1 acre in size, but have not been named. We use dissolved oxygen, DO, which is a measure of the quality of the water in the lake. So if the DO went below 5 milligram per liter, this means that there is something wrong that happens in the lake. Okay, if DO is above 5 milligram per liter, it means that the lake is in good conditions. So the amount of DO declines as waste is entered into the lake. Oxygen helps to break down the nutrient in the water. If there is nutrient, this is bad. There's no wastewater coming in. There is no industrial, municipal, there's no trash. Okay, this will add up nutrients if you add up wastewater to the lake. And this will reduce DO. So the reduction of the DO means that there is nutrients and there is waste coming into the system. And Bert et al. 2009 state that the DO content of the lake should be 5 milligram per liter, and that is the standard that we're going to follow for the open lakes. Suppose that you have collected data on a random sample of named lakes in Maine. So they collected data on the sample named lakes in Maine, and this is the data. So they went to almost 16 data location, collected water, and did the DO inside the samples. And these are the DO, 4.6, 4.4, 4.8, all the way to 4.8. Now the problem is, and you want to analyze if there is any significance difference between the data and the standard. Are these lakes in the state of Maine, are they within the standard? Are they equal to the standard? Are they less or greater? Now we have to use the t-test. This is the one column t-test. Okay, so this is the one column. If there is 2 columns, then now we're going to use something else, another t-test with 2 columns. Okay, 2 comparable columns. Now, is t-test the only way to solve such problems like this? No, there's other methods that we're going to be mentioning it later on in class. First of all, we have to put the null hypothesis that mu, what is mu? The average of dissolved oxygen data. Mu is equal to 5 milligram per liter. The average is equal to the standard 5 milligram per liter. If the null hypothesis was rejected, then we should go for research hypothesis that mu is not equal to 5 milligram per liter, whether it's equal or not equal. If it's not equal, we could check if it's greater than or lower than. First of all, I'm going to do how do you calculate the n. N is you do it normally, equal, count, that is n, number of samples. Now, I know 16 is too low, you could count it easily, but sometimes if someone gives you 3,651 data points, you're not going to count it one by one. You should just click the cells all the way down and do the count from this code. Now we should do the average or the mean, average. This is the average. You go for the data average. That's 5.52. And again, I told you that I'm using 2 decimals after the dot, or after the decimal, there's 2 digits. So I made it like this. I don't want to make it 1, make it only 2. You go down for the standard deviation, S equal STD. We do the STDEV. That's for the average, and you collect all the data, and that will give you 0.72. And of course, you have to put unit because the average has a unit of milligram. Do not leave any cell without any units. Milligram per liter, and standard deviation is milligram per liter, also 0.72, and then you find the standard error. The standard error is by dividing what? You divide the standard deviation, this one, divided by square root of course, I'm going to select this code, n number of sample, and you close it. This would give you 0.18, and the standard error is milligram per liter 2. T critical. If we have two columns, we have to find the degree of freedom. You will see that next concept. But for this, there's one column. We are comparing one column with a standard. We are not comparing two columns with each other. If you have one column with a standard, with 1 point standard, you should use this. So, n here is 16. You should go to the table, and that will be given to you in class or in the exam, 16, and then also you'll see it. Don't go to the degree of freedom. This if there is two columns, you are comparing two columns. Here we are comparing one column to a number, to a standard. So 16, you go all the way, 2.131. So this is T critical. .131. There is no units here for T critical. Now let's find T test. T test, we have to subtract the mean from the standard and divide it by the standard error. So open, equal, open the parentheses. What's the mean? This one, minus, remember the standard, 5, close the parentheses, divided by standard error, 0.18. Click. That's 2.87. Now we have to go and do our results. So the result is like this. Since the absolute value, whether this t-test is negative or plus, you have to make it positive, absolute. Since the absolute value of 2.87 is greater than the critical t value of 2.131, we reject the null hypothesis. So this null hypothesis was rejected. Now we have to accept the research hypothesis. So we reject the null hypothesis and accept the research hypothesis. Conclusion, the average level of DO in the main state of Maine named lakes is significantly greater than 5 milligram per liter. And probably, of course, close to 5.5. Why we did this? Because remember the average is 5.52. This is greater than the standard. So this lake has a good quality water. So, and we proved it statistically, since t-test is greater than t-critical, that there is a statistical increase in DO from the average DO of the lakes from the standard. Okay, and you should put the conclusion like this. You know, I know the book added the other one. You don't have to put the last sentence, but I think this is enough for a conclusion. The average level of DO in the state of Maine named lake is significantly greater than 5 milligram per liter, or greater than the standard put by the state. This is it, and I think we have to stop recording now, and we will see you in the next